Okay, for what we have regarding rational expressions, in this particular section, okay, there is a term that is referred to as restricted value. And this will be a quantity that renders a function, or in this case, rational function. As undefined in the real number system. And just for cases that we have regarding restricted values. Say we have a rational expression such as 3 over x. Okay, now for 3 over x to be defined, remember the bottom part of the fraction cannot be equal to 0. So in this particular case, we have the restricted value is going to be at 0. And let's say if we have something like x plus 2 over x minus 5. Okay. Now in this particular case, now again, the restriction is going to be with the denominator. X minus 5 cannot be 0, and we have the x cannot be at 5. So we have in the case side the restricted value. Okay, that is going to be at 5. Also, if you have, let's say if we have something like x minus 4 over x squared minus 9. Now in this one, x squared minus 9 cannot be equal to 0. And if I were to factor, now I have that if x squared minus 9 cannot be 0, neither can its factors. So in this case, we have x plus 3. This cannot be 0. X minus 3 cannot be 0. And if x plus 3 cannot be 0, well, x cannot be at negative 3. Also, if x minus 3 cannot be 0, x also cannot be at 3. So we have not one but two restricted values. In this case, okay, we're going to have at negative and positive 3. And let's say that if we have as an additional case, if I have, let's say, x plus 3 all over x squared plus 4x plus 3. And let's say if I were to put this in factored form. So I have x plus 3 all over x plus 3 times x plus 1. Now, if I were to simplify completely, now x plus 3's would cancel out, but again, restricted values, they would apply even before we have any cancellations involved. Okay, so even though x plus 3 would cancel out, still you have originally x plus 3 as part of the denominator, and that still cannot be at 0. So we have with the denominator factors, we have x plus 3 times x plus 1 cannot be at 0. And even though x plus 3 cancels, we still have, again, originally and factoring, x plus 3 is in the denominator, and that still cannot be at 0. And so, in effect, we're going to have still, just like the third case, we're going to have two restricted values. Okay, and to keep x plus 3 from being 0, x cannot be at negative 3. Likewise, for x plus 1, if this cannot be 0, x cannot be equal to negative 1. So we have here, with the restricted values, both of these are negatives. And so we have with negative 3 and negative 1.